So here we're going to be focusing on text analyses, different types of text analyses using the NLTK package and doing some processing of calculating the common terms in the messages and also doing sentiment analysis later on. So first we're going to import several packages that are pretty standard for NLTK, and there's a tokenizer, lemmatizer, stop words. Here I'm just taking the stop words. So when we import the stop words from NLTK, and the stop words are the list of very common words that are not usually interesting when we do term analysis or topic analysis. So words like as, to, by, and so on, these kind of just conjunctions. And here we're taking those stop words in English and put it into a variable though. So the names maybe get confusing, but the stop words here that we're importing is an object for NLTK, and here we're putting it into the stop words variable, and we get a length here, and this should be of 179, and I think the type now is just a list. Yeah, it's just a list of stop words. But if you do stop words, let's see, stop words, that words, which is the object. Actually, this is not going to work. Oh, we probably need to put the language. List object has no attribute. Oh, okay, so we get confused. So we overrode, because here when we first imported stop words, now we created a new, we use the same word here. So there is no words object anymore as used to. But you can check it out when you first do it and see before you run this to see if you want to check out this data type of this object here. So, and then here we have several functions that we're going to need for common text processing. And one is the lemmatize function. So remember, lemmatize takes the word and returns a root of the word. So it removes kind of the conjugations or the plurals of the word and returns the kind of the root of the word. Then we have a function for punctuation, and we have a function to remove stop words. Now this lemmatize function, it lemmatizes, well, it's called lemmatize list. So it lemmatizes a list and it receives a list. And then here there's some processing which just takes every item in the list and it lemmatizes the words in it, and then returns a list of lemmatized words. On the remove punctuation, it's a little bit simpler, and words uses list, what's called list comprehension in Python, and it receives a list of text, accepts a list of lists of tokens, and I think actually the lemmatize also accepts a list of lists. And then it's just word for word, it kind of removes, checks to see if it's alphanumeric, and if it's not, it doesn't include it, and if it is, it includes it on the object and returns that. And here remove stop words, actually I'm just going over this so you can be mindful. This remove stop words function is going to check word for word in the document if the word not in stop words. So this stop words here refers to the list, the stop words list that we had here, that we created, that we got from NLTK. So which is just a list of words like a, as, to, by, the, things like that, that are conjunctions and not very useful for understanding the topics. And then it kind of removes those here. So here we have an extra set of functions also that's going to take the data frame and it removes things that are not ASCII code. So things like emojis or other characters that are not the basic ASCII set of characters. And this one is going to apply to the whole data frame, but and I'm not even sure if this is necessary, but you can try it with it or without it, but essentially it turns the text only into ASCII, removes anything that is not ASCII code. So once again, things like emojis or other kind of funky characters. Now the way it's written here, it applies to the whole data frame. So all the other numbers, everything is going to turn into string. So, and I'm calling this sttw clean. And this is what we're going to use. So if it just, this is actually just a data frame. So I just ran that, and if you see it, except that now everything is turned into, so even I think the date, everything is a string, and only ASCII string. And because that's kind of what we need to do to feed into our functions. So the first function is the lemmatized list we're going to apply to, and notice that actually we're sending a list of messages. So actually I don't know if we're actually not, I don't think this is a list of lists. This is a list of messages to lemmatize, and then it returns a list of lists. So here we take the full data frame and we turn it into a list of messages. So only a single list of messages. Feed into lemmatize this, and I think the response is a list of lists. And then we also feed this response here, sttw lemma, into the remove punctuation function, and removes the punctuation. And then we feed it into the remove stop words. We feed this here into the remove stop words function, and then get this tw all clean. And then if I just visualize this tw all clean, what is it? Well, like I was saying, eventually we kind of end up with this list of lists. And I know it's a list of lists because I can see, okay, here we have a list. The square brackets in Python is going to refer to a list item. And if you can just, if you do a data type check, you see it's a list. So here's a list of items, a list of tokens. Now, because we have another one here, see the double, we have a list of lists. And that's because each of these was a message. The message was tokenized, and we just have the kind of main key, and remove the punctuation, and lemmatized, and remove the stop word. So we have like the key central terms of each of the messages that we can use now to understand the main terms used across all of these messages. And note also, like, we got some things here, well, HTTP kind of repeated, like, this is not that useful, so I know that each message may have a link reference, but these are not that useful for us since we're interested in finding the most common terms of what they're talking about. So we might want to remove these, and actually I ask you to do that. So actually there's a line of code here, add code here to remove that, remove those HTTPs or other kind of any nonsense you kind of see. So do a little exploration of the data and then remove that. There's different ways to do that. One way to do it is to just plug it back in the stop words. You can use append function for this list, and you can just write out all the words that you kind of see that might be remaining there, like HTTP or PM or other words. You append the lists, the words to this list, and then you run this, at least this function here again, remove the stop words. And that's how you can remove that HTTP from there, and there's different approaches as well. Now here we want to use the frequent distribution function of the NTLK to do automatic calculation of all those terms. So remember, we created this list of lists of all the key terms from all the messages. Now we can employ this frequency distribution to calculate all the common terms and just how many of each of the terms are in this list. The thing is, when we feed that into the function, it expects a list. So freq distribution expects a list, but what we have is a list of lists. So actually what we need to do is turn the list of lists into a single list. And it's actually very simple how to do that. You can do that with a simple loop, but I want you to write it yourself, and I kind of almost gave you the whole code here, but I'm just giving you the pseudocode. So you just have to loop through the list of lists and take each item and append it into a new list you create, and then you just have a single simple list of all the items, meaning all the tokens of all the messages. And then once we put that into the frequency distribution function, what we get is this frequency distribution object, which is each word and how many times they appeared. So it's got like 2 items in each. It's a kind of a dictionary. So HTTP appeared 53,000 times. Vaccine appeared 9,173 times. Case appeared 8,677 times, and so on. So once again, I want you to go back and remove some of these words like HTTP, but you don't need to remove that many, at least this one or some other ones. And then if you can double check to see what kind of object this is a probability and NTLK probability frequency distribution object. And because it's this frequency distribution object, it's got its own methods, its own functions, its own properties. And we can do something like use this most common function of this object that we now have. So it looks like a dictionary of words and their quantity, but it's a little bit more than that because it's its own data type. And then we can use this most common, and you can put 20, 10, or 15, whatever number you will have, and then you get the most common 20 terms. And it's going to look like this if you print it out. And notice that it's kind of a list of tuples, this kind of 2 items pair in Python. So what we're going to do is you want to put this in a data frame so we can plot it, because it's easier to plot it with a data frame. So we just have to loop through it and add each item to a data frame, okay? And actually I gave you the code for that. So this is a loop that takes each item. The 0 and 1 here refers to the 0 and the 1. We know we have 20, so we can use a counter to go through each. And then you just go through each and then append it to a dictionary, and then from the dictionary we can append it to a list, and then we can take this list and it's actually we're appending the dictionary to a list. Maybe it looks a little bit complicated in the beginning, but we need to work with the dictionary and then add this dictionary to the data frame. That's kind of how we can create a data frame. Take some time to look at this so you can kind of understand what's happening here. It's a very useful, just basic loop where we kind of put things into a dictionary first, append them, and then add it to a data frame. And then notice the result here. We have a data frame as we are familiar with. One column is the term, and then the other column is the count. So HTTP, vaccine, and so on, they are paired. And we can use this to make a graph like a bar graph. And then here we have a horizontal, but you can also do a vertical. And we have a bar graph of the most common 20 terms in the full data set. Okay. Once again, let's remove HTTP. It's really overly represented and it's kind of meaningful. I know every message has a link to somewhere else. I want to know what they're talking about. So here we get some of the basic terms that let me see what they're talking about. Now some of these terms maybe doesn't get to what they're talking about exactly, like get and maybe today, but a lot of the other ones do, right? So see how it goes, and then next we're going to be talking about sentiment analysis.